welcome to lecture series on data structure. In today's lecture series, we are going to see about the topic hashing in data structure. So, the main concept behind hashing is to value as. So, for example, instead I bring as an example, or take your record as an example. So in the end of record, we will have index. So what do we need of index to refer to each experiment is so corresponding to each experiment, we will have a page number. So that page number will act as the reference to the exact experiment page, correct? So similarly, there are multiple bits in the record. We want to refer them. We will have an index. For example, the technical department which are found in this particular row and column. IT department books are filed in this particular row and column. So like that, we will have a reference number. Based on that, indexing the book will be very easy. This is the concept behind hashing. So this is used for indexing the data in a database. This is accomplished with the help of hash table. Hash table it supports a subset of operation allowed by the binary search tree. So the implementation of this hash table is called as hashing. So, with the help, since indexing is made easier with the help of using insertion and deletion operation is very quick, and it can be done with an average constant time of order of 1. It is not efficient in operation that requires any ordering information among the elements, such as it is more convenient for insertion and deletion, but it is not convenient for operations such as find max, or if you want to print the entire table in a sorted order. For all these operations, hashing is not the right choice. So the ideal hash table structure is an array of some fixed size, where the array consists of a list of items. Each item is associated with a data member called as a key, which is used in calculating the index value of that particular item. So this key can be an integer or a string or any numbers or any data type. Example, a name or an ID which is part of larger employee structure can be constructed. In DBMS, we have primary key, right? So key is similar to a primary key or a super key like that. So table size is obtained by the size of the array. So each item stored in the array is indexed from 0 to n size minus 1, which is table size minus 1. But if key is mapped into some numbers in the range 0 to table size minus 1, this mapping is called as hash function. So here is an example of how this hash function works and how the data values are mapped to the data table. So here we have list of items drawn 25,000, fill 31,050, Dave 27,500, Mary 28,200 like that. Here John, Phil, Dave and Mary or these four or the key values. So with the help of the hash function, these key values are mapped to the indexes. John is mapped to index 3, Phil is mapped to index 4, Dave is mapped to index 6, Mary is index 2, mapped to index 7, likewise. So the hash function should be simpler to compute, and it must distribute the keys evenly among all the cells. If we know which key will occur in advance, it is very easier for to write the perfect hash function. If in case we do not know which key will occur in advance, writing a hash function is very difficult. At times, we have a lot of functions with respect to the key hash functions we have defined. Some of the problems are when the keys are not numeric. It is difficult to define a hash function. Writing a hash function for a numeric key is much easier, but key may not be numeric alone, can be string also. So number of possible keys, if it is much larger than the table size, again hash function will be difficult. And if different keys map into a same location, collision will occur. So not all the hash functions are collision repellent. If there are too many collision, then the performance of the hash table will obviously degrade. The input size are integers and simply key modulo table size is a general hash function that is prominently used. Unless key happens to have some desirable properties, we can use this hash function. Keys are strings. Hash function needs more care. First, you need to convert the string into a numeric value. Then you have to find the appropriate hash function. So here are some of the methods. One is truncation method, folding method, key modulo n, squaring method, radix conversion. These are some of the commonly used hash function for generic values. So here is one example as we have discussed earlier. When the input is a string, you need to add up all the ASCII values of the character of the key. The key given as a string, you need to add up all the ASCII values of the characters of the key. So we are initializing the hash value to 0. Then the hash function is calculated like hash value equal to hash value plus key of I. And the final hash value modulo table size is returned. So it is simple to implement and is much faster. When the table size grew large, this function does not distribute the key evenly. For example, assume the table size is equal to 10,000 and key length is less than or equal to 8. Uh, it means the function we have proposed here, the hash function, can assume values only between 0 and 1016. So hope you understood till this. We will continue with a few more examples in the next upcoming videos. Keep watching and thanks for listening.